All right, number 12, we're supposed to find the distance between the points 3, 0 and negative 2, 3. Now, you got to know the distance formula, so it's d is equal to the square root. That's x2 minus x1 squared plus y2 minus y1 squared. I keep simplifying. Now, let's plug in. Now, which ones you want to be x1 and y1 and x2 and y2 is up to you. I tend to write the first set as x1, y1, and the second set as x2, y2. Works out every time. All right, so x2, which is negative 2, minus x1, which is 3, squared, plus y2, which is negative 3, minus y1, which is 0, squared. So just be careful with your signs. Negative 2 minus 3 is negative 5 squared. Negative 3 minus 0 is negative 3 squared. Negative 5 squared is 25, plus negative 3 squared is 9. Listen, if you're typing this in your calculator, you need those parentheses. If you just type in this, it's going to tell you negative 25, and that's not right. You need negative 5 squared, which is 25, okay? Now, don't take the square root of each of these either. You have to add first. So d is equal to the square root of 34. If the square root of 34 would simplify, you should do it, but it doesn't. So that is the exact answer for this problem. Also, make sure you can type that in your calculator and you get the rounded answer if needed. Next problem asks us to find the midpoint. Now, midpoint is where you average the x's and average the y's. Notice it's the same two sets of numbers. I could even plot these points if you want. Here's 3, 0. Plotting not required. And negative 2, negative 3. And we're just trying to find the middle of that line. Square root of 34 was the distance. That's what we just did on problem 12. Now we're just trying to find the middle of the line. So you average the x values together, put a comma, and you average the y values together. Put parentheses around it so it's in point form. Well, if I average the x's, that's going to be 3 plus a negative 2 over 2. Remember, there's 2 of them. That's why I'm dividing by 2. And then 0 plus a negative 3 over 2. Now, 3 plus a negative 2 is 1/2. 0 plus a negative 3 is negative 3/2. If those fractions would simplify, you should, but they don't. So that's it. Now, if I try to just plot that, and remember, I did a pretty lousy graph over there, but it should be kind of close. So 1/2 negative, that's negative 1.5. So we're right there. So my graph's pretty close. That's the center. Problem 14, we're supposed to identify the center and radius of this particular circle. Now, if you'll notice, okay, a circle, let me just give you the formula, right? It's x minus h squared plus y minus k squared is equal to r squared. So if I compare that to what we have x minus 2 squared plus y, look, we're not subtracting anything. How about minus 0 squared, or plus 0, it's up to you, equals 8. Now, line everything up. Okay, so my h is 2, because there's a negative in the formula like I like. My k is 0, and my r squared is 8. All right, so when I write my center, that's going to be 2, 0. But I have to calculate my radius because r squared is equal to 8. So I square root both sides. R is the square root of 8. We've already had to reduce that on this practice. Square root of 8 can be written as square root of 4 times square root of 2, which is 2 square root of 2. Now, question 15 is a little more challenging. It tells us to identify the center and the radius, but this particular problem is not in standard form, so that's what we need to do. And to do that, you're going to group together all your x's first. So x squared plus 12x, they go together, okay? And then I can say plus, and then in green, I'm going to do my y's. That's y squared minus 6y, they go together. And then I could say equals, let's take that 4 to the other side. Now, why did I do this? So I can complete the square. I'm working with these two guys, and I'm working with these two guys, okay? Now, to complete the square, you're supposed to take half of that x term, which half of 12 is 6, and then square it, Okay, so half of 12 is 6, and then 6 squared is 36. What do I do with that? I add it. So x squared plus 12x plus 36. The fact is, I have to come over to the other side and also add 36 so my equation stays balanced. We do the same thing down here. Half of negative 6 is negative 3, but negative 3 squared is 9. What I'm going to do with 9, I'm going to add it on both sides. So y squared minus 6y plus 9, and over here I'm going to add a plus 9 also. Now I can factor. So x squared plus 12x plus 36 factors into x plus 6 squared. Notice it factored into my half number. That's what's going to come right down here. And then plus, over here, that's going to be y minus 3 squared. Because look, there's my half number. There's my minus 3. On the other side, I'm going to have 49. Now from there, I can tell that my center is negative 6, 3. Well, what's up with that? Well, the formula for a circle has a minus in it. So you always take the opposite sign for your x and for your y. So if it says plus 6, I have a minus 6 for my x value of the center. And since it says minus 3, I have a plus 3 for my y value. If you look at the last problem, the same thing happened. Okay, so minus 2 meant I had a center of plus 2. We weren't subtracting anything from y, so that sign doesn't change. It's just 0. So back down here, I also have my radius to figure out. And my radius, my r squared. So I have r squared is 49. You know what that means? R is 7. So there's my center, there's my radius. And this problem works backwards. Okay, write the equation of the circle with center negative 1, 4 and radius 5. So remember the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. So it's going to be x minus my h is negative 1. So x minus a negative 1 squared plus y minus my k is 4. And I have 5 squared here. Now these two negatives turn positive. That's x plus 1 squared plus y minus 4 squared is equal to 25. That's the equation of a circle. No need to multiply it out. If you do your quick check and think backwards, notice the center's negative 1. Change the sign. Negative 1, positive 4 is exactly what was asked of us. And the square root of 25, which is 5, is our radius. For problem 17, we're working with complex numbers. And when you work with complex numbers, what you're supposed to do is simplify any negative under a radical. Remember, that's an I value. So this negative square root of 3 right here, square root of negative 3, I'm going to take the negative out, and that's an I. So I have I square root of 3. I can also simplify the square root of 12, or we can wait till after if you want to. That's up to you. But now I can multiply these two numbers together. That's I times the square root of 36. Hey, we know the square root of 36 is 6, so that's I times 6, better written as 6I. This next one, again, don't work with negatives under a square root. That must be the first thing you do. So this is going to be 3 minus, okay, because of the square root of a negative, that's an I value, and the square root of 4 is 2. So the square root in this case just disappears. So it's 3 minus 2i plus, notice there's a big plus between these, negative 8 plus, now the square root of negative 25. Again, the negative part under a square root is an I value. The square root of 25 is 5. Now you can add like terms. Look, you can add the 3 and the negative 8 together, because that's the real number part, which gives you negative 5, and then you can add the negative 2i and the plus 5i together, and that's going to give you plus 3i. And this is standard form for a complex number. Now remember how I said you cannot work with a negative under a square root, so I'm going to rewrite this problem. Again, this is 3 minus 2i. Remember, we simplified that in the last problem. The square root of the negative is the I part, the square root of 4 is 2. But notice there's nothing between these sets of parentheses. This is multiplication. So negative 8 plus the square root of negative 25. Again, the negative is the I part. The square root of 25 is 5. So 5i. But since this is multiplication, I need to FOIL. 3 times negative 8 is negative 24. 3 times 5i is 15i. Negative 2i times negative 8 is plus 16i. Negative 2i times positive 5i is minus 10i squared. Now combine like terms. 15i plus 16i is 31i. And then I squared is negative 1, negative 10 times, so always replace I squared with a negative 1. Then negative 10 times negative 1 is plus 10. But we can keep going because we can add negative 24 and a positive 10 to get negative 14 plus 31i. All right, my next problem. Again, not allowed to work with negatives under a square root. So if I simplify that, that's 2 minus I square root of 3 squared. Because I couldn't take the square root of 3, so it stays underneath. Now what you want to do is write that out twice. Don't search squared in each part because that's not how it works. When you have a binomial squared, you write it out twice. Then you FOIL. 2 times 2 is 4. 2 times negative I square root of 3 is negative 2I square root of 3. That's about the best we can get that. And then I square root of 3 times 2 is another negative 2I square root of 3. Notice because the 2 is not under a square root and the square root of 3 is, we can't multiply those together and get like square root of 6. They have, if it's out, it's out. If it's under, it's under. That's the best we can do. And then finally, negative times negative is positive. I times I is I squared. Square root of 3 times square root of 3 is the square root of 3 squared. So now I have 4. Now these are like terms. That's going to be minus 4i square root of 3 because we're dealing with the coefficients in front. So I'm taking negative 2 plus a negative 2 to get negative 4, and I bring over the I square root of 3. That's the like term part. Over here I have plus. Now I squared, remember, is negative 1, and square root of 3 squared is just 3. Let's keep going. 4 minus 4i square root of 3. And negative 1 times positive 3 is minus 3. 4 minus 3 is 1 minus 4i square root of 3. All right, for 17e. Again, not allowed to work with negatives under a square root. So this is equivalent to saying 6 minus. Now the square root, the negative under a square root is your I part. You also know the square root of 64 is 8, so I can write that as 8i over 2. Now, whenever you're dividing by a whole number, you're allowed to just, not a whole number, but a non-imaginary number. Could even be a decimal. You can divide each one of those by 2. That's going to give you 3 minus 4i, and that's all you have to do. But now, on the one on the right, there's a lot more work to be done. Why? Because when I simplify this, watch out, 1 over, now this is going to be 3 minus, again, the negative under the square root is I, and the square root of 16 is 4. So it's 3 minus 4i. These problems are completely different. This is dividing by a real number, no i's. Whenever you're dividing by I, you have to multiply by the conjugate of the denominator. What is that? In this case, it's 3 plus 4i. In both the numerator and denominator. Now in the numerator, 1 times 3 plus 4i is just that, 3 plus 4i. In the denominator, I've got a FOIL. 3 times 3 is 9, 3 times 4i is 12i, and then negative 4i times 3 is negative 12i, and negative 4i times positive 4i is negative 16i squared. So I have 3 plus 4i over, now 12i minus 12i cancels, the negative 16i squared, remember I squared is negative 1, so that's 9 plus 16. So I have 3 plus 4i over 25. But then I have a problem like I started with here in E. I need to split it up. So it's 3 over 25 plus 4 over 25i. If those fractions would simplify, I would, but they don't, so I won't. All right, we got 1 plus the square root of negative 9 over 3 minus the square root of negative 36. Remember what we have to do first? We have to write this without the negative under a square root. Now, the square root of the negative is I, but the square root of 9 is 3. So numerator is 1 plus 3i. Denominator 3 minus, again, the negative under the square root is I. The square root of 36 is 6. So that's an equivalent expression, and it has to be done before you can do anything else. Now, when you divide, and you have an I in your denominator, you multiply by the conjugate, which means you keep the same side of the first or the real part, and you change this operation in the middle. And you do that on the top and the bottom. 3 plus 6i in the numerator, 3 plus 6i in the denominator. Okay? Now, we need to FOIL in both the numerator and denominator. What I mean by FOIL, first, outer, inner, last. So 1 times 3 is 3. 1 times 6i is plus 6i. 3i times 3 is plus 9i. 3i times 6i is plus 18i squared. Denominator, I'm going to do the same thing. 3 times 3 is 9. 3 times 6i is plus 18i. Negative 6i plus 3i is minus 18i. And negative 6i times positive 6i is minus 36i squared. Now in the numerator, I have 6i plus 9i is 15i. Remember, I squared is negative 1, so that's minus 18 now. Denominator, plus 18i and minus 18i cancel out. Y'all, that should happen every single denominator. It's always what happens when you multiply a value times its conjugate. Now, 9 minus 36i squared. Remember, I squared is negative 1, so it's going to be 9 plus 36. I keep going. 3 minus 18 is negative 15. Always write your real part first, and then plus 15i, your imaginary part second. 9 plus 36 is 45. I divide each one of these terms, or the real part by 45 and the imaginary part by 45. These fractions will simplify. 15 goes into 45 3 times, so that's negative 1 over 3 plus 1/3 I. Completely simplified. The next problem, let's do in pink, 2 minus I over 3i. I'm going to write it a little bigger. 2 minus I over 3i. Again, if you have an imaginary in the bottom, you need to multiply by the conjugate. You might be thinking it's missing the real part, right? Well, it's like a 0, like 0 plus 3i. So we need to multiply by 0 minus 3i. So let's do negative 3i in the denominator, negative 3i in the numerator. Listen, whatever's in the bottom has to go in the top. Always the same numerator and denominator here. I'm going to distribute. So 2 times negative 3i is negative 6i. And then negative I times negative 3i is plus 3i squared. And the denominator, 3i times negative 3i is minus 9i squared. Excuse me. And then remember that I squared is negative 1. So I have negative 6i minus 3. And then again, I squared is negative 1. That's going to give me positive 9. Listen, that numerator is backwards. Let's write it in the right order. So negative 3 minus 6i. Just take the signs with the numbers. Take the negative with the 3. Take the negative with the 6i. Over 9. Split it up. Negative 3 over 9 minus 6i over 9 gives me negative 1/3 is my real part. And then 2/3 I is my imaginary part, and that's negative. And I believe this is our last imaginary number problem. So notice it's a big one, but it's already in terms of I for us, so we don't have to take a negative under a square root and turn that into an I. The 2 minus I squared I need to FOIL out. That's 2 minus I times another 2 minus I. The 3 in front of the 2 minus I can distribute that. Plus 3 times 2 is 6. And then 3 times negative I is minus 3i. And then the minus 5 I'm just bringing down. So I'm going to FOIL here. 2 times 2 is 4. 2 times I is negative 2i. Negative I times 2 is another negative 2i. Negative I times negative I is plus I squared. Okay, I'm just recopying the rest of this. But if you wanted to go ahead and say 6 minus 5 is 1, you could. Okay, now, if you want to go ahead and combine like terms, so notice I got a negative 2i, another negative 2i, and a negative 3i. So that's going to be negative 7i. Go ahead and write that down. Here I have 4 plus 6 is 10. 10 minus 5 is 5, so plus 5. And then look, I have this I squared term. Y'all remember that's minus 1. So I still need to combine those together. 5 minus 1 is 4. I'm going to write it in front because real parts go in first. And then minus 7i in the back. And that's completely simplified.